Okay, so the next section that we're going to talk about is section 2.2, Fundamental Chemical Laws. So we're going to talk about three different scientists who contributed to what we know about chemistry today, and the three different fundamental chemical laws that they came up with. So the first chemist is Antoine Lavoisier. So he proposed the law of conservation of mass. So he did a bunch of different experiments where he was comparing what he started with what he ended with to see if the mass was the same. So he was burning stuff inside closed containers, and he found that the mass that he started with was the same as the mass after the reaction occurred. So the law of conservation of mass states that mass is neither created nor destroyed in a chemical reaction. So you don't gain any mass, but you also don't lose any mass. Joseph Proust proposed Proust's law, or the law of definite proportion. So the law of definite proportion states that a given compound always contains exactly the same proportion of elements by mass. So we'll talk about an example for this so it makes a little bit more sense. So we're going to look at water as our example. So water. So water consists of two hydrogens and one oxygen atom. So if we look at the mass for each element, hydrogen is 2 grams per mole for the two atoms. Oxygen is 16 grams per mole. So if we add those two numbers together, we get the total mass of the compound for H2O, or water, which is 18 grams per mole. So now we can compute our ratios by looking at the mass of hydrogen compared to the mass of the total molecule. So 2 grams per mole over 18 grams per mole. And for oxygen, 16 grams per mole out of 18 grams per mole. So when we do that math, and we can multiply by 100 to get our percentages. So for hydrogen, we get 11%, and for oxygen, we get 89%. So this tells us that everywhere, no matter how much water you have, whether you have 50 gallons or 1 mole, the ratio of hydrogen to oxygen is always 11% and 89%, which is approximately 1 hydrogen for every 8 oxygen. So the last scientist is John Dalton. So he suggested that elements were composed of tiny individual particles. And for a given compound, they always contained the same combination of those atoms. So this resulted in the law of multiple proportions. So he said when two elements form a series of compounds, the ratios of the masses of the second element that combine with 1 gram of the first element can always be reduced to small whole numbers. And this will make a lot more sense here in a minute when we talk about the example problem. So this example shows us data that were collected for several different compounds of nitrogen and oxygen. So the table lists the mass of nitrogen that combines with 1 gram of oxygen. So for compound A, 1.750 grams of nitrogen combined with 1 gram of oxygen. For compound B, 0.8750 grams of nitrogen combined with 1 gram of oxygen, and for compound C, 0.4375 grams of nitrogen combined with 1 gram of oxygen. So for the law of multiple proportions to hold, the ratio of the masses of nitrogen combining with 1 gram of oxygen in each pair of compounds should always be small whole numbers. So we can compute the ratio as follows. So compound A's mass of nitrogen over compound B's mass of nitrogen. So, and I'll just illustrate my point by showing that those two numbers are the masses of nitrogen that combine with 1 gram of oxygen. So when we divide, we get a ratio of 2 to 1, which reduces to just 2. So our small whole number for the ratio of A to B is 2. Okay, an example continued. If we do compound B over compound C, we get a ratio of 2 over 1. And compound A over compound C, we get a ratio of 4 to 1. So again, these numbers are the mass of nitrogen that combine with 1 gram of oxygen. And the law of multiple proportion states that these numbers for each compound can be reduced to small whole numbers. And that is what we have here in this example. So B over C equals 2 and A over C equals 4.